Hello, my name is Gabriela Mateo. I'm a TA1 and I'm going to be covering sample size. Now, why is sample size so important? Sample size is important because it's one of the four determinants of a statistical power. These four determinants, as described by this mnemonic pain, are power, alpha or level of significance, the number of subjects or sample size, and the effect size. Now, we know that alpha or the level of significance is usually set as a standard of zero point zero 0.05, the p-value of 0.05. And this is our willingness to commit a type 1 error, meaning the lower the level of significance, the lower the p-value, the higher our confidence that we are finding a true effect, the higher our confidence that the rejecting the null hypothesis is correct. And therefore, the lower the chances of committing a type 1 error of rejecting the null hypothesis when it's actually truth. Because we don't want to pretty much say that this test is effective, like this intervention is effective, when it actually isn't. So the lower this level of significance, the lower, the chances that we will commit a type 1 error. Now, the same thing goes for beta in computing power. Power is 1 minus beta, and beta is basically our chances of committing a type 2 error, meaning our chances of failing, meaning not rejecting the null hypothesis when it's false, meaning that this test was actually not efficient and then we failed to reject it and we actually accepted it. So either way, it's wrong. So like when we set up beta of 0.20, we're pretty much saying that we're willing to commit, we are willing to take a chance of 20% of committing a type 2 error. So the power, if we set a power of like, let's say if the beta is 0.20, then the power will be 0.80, which would mean the power will be 80%. And difference in the alpha, the power is not a standard. It would really depends on how strong we want the effect. We want, the significance or the statistical power. And this is why we have to decide on all these different determinants to basically decide on how powerful we want this statistical power of this study, of this test, of this intervention that we're investigating. And then alpha and power don't kind of have like a math, they don't add up to, they don't kind of like have a like combination of like mathematical combination, but they kind of complement each other because the higher the alpha, the lower the power, the higher the power, the lower the alpha can be, because since we're both working with type 1 and type 2 errors, we have to kind of like interchangeably work with them because if we set an alpha level, for example, of 0.01, meaning that we're setting up a p-value of very low, meaning that we want to make sure that we're not committing a type 1 error at all. We don't want to reject the null hypothesis when it's true. Then that means that our chances of failing to reject the null hypothesis when it's false will be higher. So we need to be careful about these values that we set. Then just to jump over sample size, when it comes to effect size, this would also depend on the type of intervention, the type of a statistical test that we're performing. If we're looking at the difference in, two different groups and we're looking at their mean values, then, their effect size will be this difference in mean between the two groups' means. If we're looking at a correlation, for example, maybe we're looking at how big is the association between two different variables, the variables that we're looking at correlation for, right? So if we have three of these determinants, we most likely can find the third determinant. And then this is a little bit of introduction of why sample size is very important. But sample size is basically how many participants are needed for the power, for us to have significant results, for us to be confident that our results in our study, that the difference, the effect size, all of these things that we have decided on in our test are significant and are true. And then this should always be decided during the power analysis of the study. Like I said before, when you're looking for the statistical power, when you're planning on the statistical power of the study a priori, that's when we should be deciding how many participants that we need to acquire the power that we want to acquire, right? So should we pick as many participants as possible, or should we go with just just little? What the problem with picking as many participants as possible is the limitation of our resources. It may be expensive. I mean, we may also be exposing participants that don't need to be exposed to a new intervention, because maybe we don't need to include that many participants to have a high power, to have a good power in a study. So when it comes to too little participants, on the other hand, maybe we don't have enough participants to acquire power, and therefore the little participants that we're exposing to this new intervention that may not even be effective, it's not worth it. So we definitely need to we need to plan a priori. How many participants do we need? A really good, not a good standard, good amount, that we're not exposing people to risk, and that we're also not exhausting resources. So how do we calculate sample size? Like I said before, we can use some of the other determinants to calculate sample size. Nowadays, it's really easy to calculate sample size with some of the statistical softwares like Stata, SPSS, or R, but we still need to find the values of the other determinants to be able to put them in for the sample size to be calculated. So we already talked about significance level, and this is basically how much we're willing to compromise, committing a type 1 error. The same thing for the desired power. We just have to decide on beta, whether we want 80%, 90%, how much, what are the chances that we're willing to commit a type 2 error? And then, 1 minus this beta will be like either 90, 80, whatever we decide. Now, 3 and 4 are kind of intertwined, and this is about finding an effect size. So first we need to find the characteristic of our outcome, so then we can decide, or we can search for the effect size that we look. So if, like the example shows here, the variability in the outcome, it depends. If we're looking for a variability in an outcome, then we may want to choose in the standard deviations. But more simple examples are, like I explained before, like if we're looking at the difference in means between two different groups of a certain, tests or results, of a performance, or maybe like a pain value, like after, on medication, something like that, then we just want to see the difference between the two groups' means, and that's going to be our effect size. If we're, for example, looking at correlations or any observational studies, maybe we want to look at the size of this, relationship between the two different variables. And then that's going to be our effect size. Now, how do we find effect size? Usually the effect size is going to be in our literature reviews. It's going to be based on prior studies that were done and pilot studies that were done, and studies that have already studied other populations and have found that, they found, a good effect size for your study. If you cannot find, if your study is too novel, then maybe you may have to run a pilot study so you can figure it out what is the proper effect size that you're looking for. Meaning, how many participants do I need to find this effect size? So first, if you don't have how many participants, now maybe you need to know what is the effect size that you need to find, in order for your test to be powerful, or your study to be powerful. So therefore, how many participants would I need to be able to acquire this effect size? I hope this all makes sense. And something that is not here that is also very important when it comes to calculating sample size, like after we have our sample size, it is important that we add a certain, we have to decide on, or maybe plan ahead for like maybe 5% or 10% or whatever percentage you think you can expect of participants to drop out, or attrition, or loss to follow up. Because if your study has these limitations of, being difficult to follow participants or something like that, then maybe you will not complete the study with as many participants as you originally enrolled. Your sample size would be diminished, and therefore it would affect at the end the results of your study. So after you calculate, your sample size, you want to add a little bit more, just to cover your basis when it comes to like attrition, loss to follow-up, and things like that. Now, this is just a quick example of how Sample size calculation should be included in your methods and in the methods explanation. And this is an example of a study that was looking at gestational diabetes mellitus. And then they explained during the methods section of the study that based on previous literature and estimated of incidence of gestational diabetes mellitus, researchers in the exercise study determined that a sample size of 352, 176 per group will have the ability to detect reductions in risk of 35% or larger, meaning this is the effect size, with a statistical significance, here's the significance, alpha 0.05 for a two-sided t-test. And also the power for screening glucose, they set up 80% power to detect a clinical significant mean difference as small as 5.99, which is your effect size based on a standard deviation of 20 milligrams per deciliters. So this is like they wanted to detect reductions to risk of 35% or larger. And then the effect size that they found in other studies was that they wanted to acquire was a 5.99 nanometers per milliliters. And then they even included deviation. In this simple, small paragraph, they included all the parts that they needed to include about sample size calculation. And this is how you should be reporting sample size calculation. This has been, and thank you very much. Let me know if you have any questions.